Hello, this is session 23 in our series of creating a stock price prediction dashboard with Python and Streamlit. Last session we completed the create LSTM model, and now with LSTM and RNN model creation we need to work on converting the raw time series data into a format that will be usable by LSTM and RNN models. We have the models, we have the data, now we need to convert it into the format that is acceptable. So we can later on train those two models with that data. So here is the sequence data method. As I mentioned, the purpose of it is the conversion of raw time series into a format usable by LSTM/RNN models. Specifically, the normalization of the data, creating sliding windows or sequences, and producing the X and Y pairs for supervised learning. The function signature goes for the data, which is the raw price series. So it's typically one dimension array. The lookback, which is the number of past time steps for prediction. 60 here is common because it's roughly 3 months of trading data and captures shortened medium-term momentum. Now let's proceed with the coding. Let's have our one-liner, prepare sequence data for later use by RNN/LSTM models with proof pre-processing. First, we want to normalize the data to prevent issues with scaling. Typo. Data mean raw data, NP mean data, data STD, standard deviation, not the bad thing that you can think of, NP STD data. We will cover this one by one after completion. Normalized data equals data minus data mean divided by data STD plus 1 E minus. Let's cover and then move on to the next. Why we have this? Because data normalization is mandatory for LSTMs. Are sensitive, the neural networks are, which LSTM and RNN both are. They are pretty sensitive to scale. Price values may range from single digits, hundreds, or thousands. The normalization will create centered data around zero. It will ensure consistent gradient magnitudes and improve the convergence speed. Why do we store mean and standard deviation? They will be needed later for denormalized prediction, convert model output back to the real prices. This abnormal sim value, it prevents the division by zero. It is kind of a precaution method to avoid prediction by null, division by null error. Now let's build the sequence. X, Y will be the empty lists. For E range, look back, and length of not data but normalized data. We want to end X normalized data I back I, and for Y to append normalized data I, and here to return for this method we want numpy array X, numpy array Y, data mean, and data. Let's talk a bit about what we have here. We are constructing here sequences. X for input sequences, look back windows, you can see it here, and Y for target values, which are the next time step. The for loop or sliding window loop, what this data will create conceptually. Let's add here, after each code, one example. X, well, the first element will be the data in range 0 to 60, and it will, oh sorry, not you, after both of them, because we are going to use also one. So, example, X 0 will be equal to data 0 to 60, and Y 0 be data 60. So, and example 2, 1 will be the data range from 1 to 61, while Y1 would be data 61. What does this do? This teaches the model, given the latest 60 timestamps, prepare or predict the next one. At the end is the return of the method. We are converting all the results to numpy array. It is required by TensorFlow Keras, which we'll be using in training methods here. The shape will become for X samples, look back, features, and for Y it will be samples. Mean and standard deviation are returned for post-processing and consistent interference pipelines. So, long story short, this method that we created, we are defining what the model will see. And together, this method and LSTM creation method, they will form a complete production ready pipeline which later will be used to train LSTM model. And this one of course will be used for training the RNN model, the one that we created before LSTM. This is it for this session. As I mentioned, next couple of sessions will be designed for training RNN and LSTM models. Thank you for your time. Stay tuned.